We're going to go ahead and get started. Hello, everyone, and thank you for joining our session, Critical Power Back to Basics. This is the first webinar in our Data Center Sustainability series. My name is Rachel Emanuel, and I'm today's moderator. Before we begin, let me highlight some features of this webinar platform. There is a Q&A panel to the right of the slides. During the presentation, you can submit questions at any time by entering them here. Our speaker will address as many as possible at the end of the presentation. You will receive an email later this week with a recording of this presentation and a copy of the presentation material. I would like to start off by saying Happy Earth Day. Today is the 50th anniversary of Earth Day, and this year's theme is climate action. Data center companies are increasing their sustainability commitments and are already implementing innovative approaches to help us achieve a net zero carbon future. That is why we're here today. With that in mind, we are kicking off this 5-part series that covers sustainability trends and innovative technologies that support reliable data center operations while consciously managing environmental impact. Upcoming sessions will run in 2-week intervals through the middle of June. You can find the registration link to sign up for the remaining webinars in the reminder email you received for this session. Can everyone hear me okay? I'll keep going. Your speaker today is Dave Sterlace, who's the Global Head of Technology for Data Center Solutions at ABB. Now I will turn it over to him.
Thanks, Rachel, and welcome, everyone. I'd like to begin with apologizing for some technical difficulties we had on the earlier session, but we will record this one. And so if you weren't able to make that one, hopefully we'll be able to get you up to speed on this one. Anyways, to begin with, let's talk about sustainability in general and what's going on in the internet. Then we'll talk about some data center infrastructure and topology and what that means and how it's evolved. Look at power quality. Look at some challenges with renewable energy and how to integrate that perhaps in a better way or a smart way. And then also what we're looking forward to in the future. I think the future is indeed bright for this industry and for sustainability in general as we learn more and can use our resources and our time wiser. And after that, we'll have some time for some questions and answers. And I hope you enjoy it. So as I said, we're going to begin with kind of some definitions around sustainability and what the industry is doing. So I think the easiest way to do that is really for data centers this year in 2020, this is our current view of what sustainability can mean to data centers. So first and foremost is really sourcing your energy in a responsible way. Right now, your source of energy can be through renewable generation, primarily done through power purchase agreements with existing utilities, which is a very good way to do things, and many of the industry giants are already doing that. And then also we're starting to see grid participation. So a data center being such a large energy consumer, but also at times an energy producer when they're on backup power or alternate power, can be more of a integral part of the grid, can really do that. And we're seeing in some areas where things like frequency response, et cetera, are starting to be used by data center operators. Beyond that, and probably where we'll spend the most time, is around efficient consumption. So this is a way for data centers to better use the resources they have. And we'll talk about where this all started and where this has come to. But certainly, topologies are the way that we can look at this from a holistic point. And then also on the IT side, what we can do with workloads, as well as how we utilize our critical power infrastructure. and a real brief look at what the state of the art looks like, or what it could be. And then finally, of course, you got to look at the circular economy, the entire life cycle of the data center itself, what the assets are doing, how we can manage the end of life. I think that everyone knows that data centers go through IT refreshes every few years. That cycle seems to be becoming shorter, and then how do you work around that? We'll touch on that, but that won't be really the focus entirely of this. But certainly the asset performance aspects will be. So it's always good to take a perhaps many of you have seen this, but I really enjoy these. What happens in an internet minute? Some folks are having issues with audio. I apologize. Not sure if I'm not sure if you can hear me. Put a thing up, so hopefully most of you can hear me. Anyway, what's happened in the preceding year? TikTok has come in the bottom. TikTok has become prevalent as on the internet. Perhaps you've seen that, and if you look at the bottom, there's 1,400 downloads of TikTok per minute right now, and this was before. Thank you, Milan. This was before the current work from home and stay at home era. So I'm sure it's quite a bit more to that. So that's changed. If you look at Twitter, year over year, Twitter is more than doubled. 87,500 people tweeting, and then now it's more than 195,000 people tweeting. So it's more than doubled year over year, which is surprising for a platform as established as Twitter. So just to show kind of what's happening, where the internet is headed. I always like to look at this. The other question we always get is where are data centers located? So data centers anymore are really located where population density has become. Things like content delivery networks, demand low latency, any sort of financial transactions, of course, demand low latency. So if you drew a 10 millisecond latency circle around Northern Virginia, which is the one to the far right, Dallas, which is in the center, and then Phoenix on the left of the slide, you'll see that covers 90+% of the U.S. population. And you can also see why that Northern Virginia, the far right, is perhaps one of the busiest areas on the whole internet. Certainly that's where a lot of overseas traffic comes in as well. So it's a tremendous location for data centers in Northern Virginia. So just give you an idea. Now, with sustainability in mind, of course, that doesn't necessarily mean that it's the ideal spot to use renewable energy, for example. You might be in a more urban area, but certainly this is a place where it makes sense to locate a data center, and we'll see what that looks like as well. So when did all this begin? Well, in 2006, the EPA commissioned, and in 2007 came up with a report, or Congress commissioned in 2006, I should say, and in 2007 came up with this report that showed energy usage of data centers that could really mushroom over time and become a large portion of the power use in this country. So at the time, at that 2006, where they started the report, it was using 1 to 2% of the electricity in the United States, and then you can see it if you follow the quote unquote historical trends or the top line, it could have gone up more than double in the next few years. So this started ringing alarm bells, and this started us taking a very a detailed look at how we're using energy and what we could do better, essentially. And at the time, things like segregation between hot air and cold air weren't really being done as much. They were just kind of on the forefront. There's a lot of still raised floor. Data centers weren't quite as big as they were. And the temperature inside, for example, was kept at a very low level. So these are some things that quickly became obvious that we could change or perhaps do a little bit of it different. With that in mind, let's take a look at the topology, look at the infrastructure around it. So ABB, of course, is a electrification manufacturer, and a lot of what we look at and what I look at every day has to do with the topology. So in the far left, we'll see the topology around the original configuration. So this just allowed you to run the critical load. You had a UPS to keep the power to filter and keep power quality up. And then on the main switchgear, we had the choice between running a genset or running utility power. So this gave you an effective way to run the data center. Now, of course, over time it became apparent that if the generator didn't start for whatever reason, or the UPS wasn't functioning right for whatever reason, then you would drop your load. So then in the center, we went to something called an M+1. So we gave the generators, basically, we added more generators to that. So if we needed 3 generators, we have 4. That way one could fail, for example, and you'd still carry the whole load. Similarly, on the UPSs, we added M+1 to the UPSs. So if we had 3 UPSs, we would use 4. And this led to some redundant equipment, but it also allowed you to vastly and greatly increase the uptime and the availability of your data center. So this was the next configuration. Later on the far right, that is the 2N+1 configuration, and this is what is being used, or what when the Uptime Institute came out with tier levels. This would be something like a tier 3 or tier 4, configuration. And what that allowed us to do is we had both dual utilities, we have can be fed from generators on each side, M+1, so dual UPS banks, and then downstream we had a dual corded load. So critical load A and critical load B would feed into the UPS or into the computer room. So each server then could be fed from either utility 1, utility 2, or the generator bank. And similarly, this led to a lot of very high availability. And tier 4, I believe, is something like downtime is calculated to be to the effect of just a few seconds a year. So barring normal maintenance and things. So this gives you a lot of flexibility and a lot of uptime. But the thing is, what we're seeing is that if you have both utilities able to support 100% of the load, then you actually have infrastructure for twice what you need, or inversely, 50% utilization. So you actually have over-provisioned your infrastructure. And similarly, if you think that feeding the UPSs, again, we have +1 on each UPS and +1 on each generator, so we have a lot of excess equipment here. So it leads to, it's a very expensive configuration. It's very complicated to run and to figure out. So this was about the state of the art when we talked about that EPA report and when we started looking at things. This was needed for financial transactions, but if you think of something that is less dependent on time or latency, so perhaps not video, but still pictures, then you wouldn't necessarily need this type of approach. From this, then, we developed some newer technologies or newer topologies that utilize the resources a little better. The first one that came up was what we call the shared or distributed redundant series. So this is essentially a 4 make 3. So if you look at it, we have 4 sources. We've distributed the generators, so there's no longer any generator paralleling gear, which makes it simpler. And then downstream, we have individual UPSs, where if you see from left to right, A and B share a load, B and C share a load, C and D share a load, and A and D share a load. So this allows you to support the loads without having that 50% overcapacity. So what happens is we have 1 extra genset and UPS, or 33% over provisioning, and then all the time our utilization is at 75%. So we've significantly improved what we use in terms of the critical power equipment without giving up too much in terms of the availability and the reliability of the system. So the redundancy on the IT side, of course, again, we're using dual corded servers and dual UPSs. And then, of course, the load management aspects of it gets a little complicated. But this is a little easier and much less resource dependent or resource overuse as the previous system. More recently, some clients have gone to things that are the block redundant or the catcher systems. What this introduces, so you can see the top looks very similar to the previous, but now we have on the far side a catcher distribution board, and then we're switching between IT loads through an STS. So we've added 3 STSs down at the bottom. STS is a static transfer switch, so it allows you to switch between loads very, very quickly. And then this allows you to get single-corded topology on the IT side, which saves a lot of copper, obviously. But there is, of course, some concern by some clients around, is the STS reliable? Could that be a potential single point of failure, et cetera? But similarly, this lightens up the load and makes the resources much more efficient in terms of how we can do things. So that's kind of where we see that the kind of the best choice currently is this type of approach for the most efficient consumption. I wanted to look at power quality just because there's a significant amount of effort in the power quality field, and there's some things that aren't as well understood. So let's take a look at some basics here. First one is harmonics. UPSs are power electronics. IT equipment is all DC powered, so it has switch mode power supplies, power electronics in it. Almost everything in the data center is running on power electronics. So with that in mind, the IT equipment itself has a power supply. It's based around, typically right now, even now, it's a Class 80 power supply. What that means is it is 80% efficient, which doesn't sound very efficient. So we've come up with a Class 80 Plus, which is a more efficient power supply. And these, as you can see by the bottom waveform there, they do distort the current, period. So there is some issues with, once you distort the current, that adds heat, that adds harmonics. Harmonics are basically frequencies outside the normal. So the top waveform you can see is a nice sine wave. When you add harmonics, when you add these switch mode power supplies, you start adding other frequencies in there. They reflect back in the system, and you start to get the distortion as we see down below. So once you start that affects how your motors operate, that affects how transformers operate, it affects the efficiency of your cables, and it adds heat, essentially. The bottom bullet is really can be very, very impactful for a data center, because if you have a lot of harmonics content, utilities will charge you extra for supplying that type of power to you. So there's a power quality charge with that, and it's typically referred to as power factor charge. So with that in mind, this can really affect your bill. So if we have more, or affect your spend on electrical. So if we can have a more efficient way to do this, simple things like using more up-to-date power supplies really can make an impact on this. So rotating machinery, typically use frequency drives on there. The more pulses of the drive, the less likely it is to deal with harmonics. Transformers, we design transformers that are designed specifically for nonlinear loads that allows to do that. So this is something just to be aware of, and it is impactful. I'd like to talk about renewable energy. I think everyone understands that key to sustainability is really renewable energy. So renewable energy, when used in the data center, and we can talk about where to use or how to use, but there are some challenges inherent within renewable energy. And I mentioned at the beginning we were talking about sourcing through power purchase agreements. Um, I think that that's remains the way to go, but some folks are talking about on-site renewables. But to take a step back, if we look at solar power from the generation side, this shows what a power plant, what its load is, what it has to put out in California during a typical day. So from left to right, you'll see that the top line, if you can see it says 212. And in 2012, there was a little less impactful. Now the much darker lines are what has happened over time. So the peaks and valleys you see have gotten deeper. And what this means is that the utility must supply power to offset. The middle of the chart is noon, so that's why it starts to dip down more solar on the grid. It starts to offset, or needs to offset, the impact of adding solar power to the grid. So it needs to actually supply less power from the traditional source. So this really makes it a challenge for the utility company to manage their peaks in their demands. It's much more dynamic and variable than it was in the past. This can impact the grid stability, of course, and it can also be a factor to consider when you're looking at where you're locating your data center. Obviously, we want to use more renewable energy, but this conversely, in some cases, has resulted in needing more what they call peaking plants or power plants that are able to spin up very quickly. And unfortunately, some of them have been oil powered or natural gas powered and not quite as efficient, both power wise or as green as we could compared to like a hydro plant, but you can't spin those up quite as fast. As a combined cycle gas plant can take literally days to start up, as can a nuclear plant, of course. And those are able to generate power at a much lower, or much higher efficiency, I should say, and a much lower cost. So conversely, unfortunately, adding renewables sometimes adds to your power bill as well as adds to your headaches in terms of how to manage how things happen with it. But again, this is part of the responsible sourcing thing, but it is something that we do need to be considerate about. So with that in mind, let's take a look at our path forward. And I think the industry itself has done a great job over time. Corporate renewables, look at these. These are the top 10 corporate renewables. And you see the largest one, purple is wind, blue is solar. The largest one is Google, and that's over 2,600 megawatts in renewables that they use. Next up is AT&T, which could be argued is a data center or a data center adjacent company. Microsoft, Facebook, Amazon, and QTS. If you don't know who QTS are, they're a co-location provider. So very good corporate citizens in terms of sustainable energy purchasing and use. So this is first and foremost in the industry, and I think that we should be very proud about how we do this. Public policy has also changed. You see on the left there, the EU has declared that data centers need to be carbon neutral by 2030. So in 10 years, we need to be carbon neutral as an industry. So again, the size of the data centers was surprising. So in the EU, we have some data centers that are operating hundreds and hundreds of megawatts, and their incoming power is at the hundreds of kilovolt level. So this is really at transmission level voltage. This is the largest industrial plants don't typically even take power at this high a voltage and at this much of a consumption level. These are almost city type loads that the data centers are adding. So with that in mind, it makes sense that you want those to be carbon neutral as quickly as possible. It puts a burden, of course, on the operators and the owners to get there, but there's ways to get there. And in fact, the companies have really not followed suit, but led the ways. We may have seen earlier this year that Microsoft will be carbon negative. So they're actually removing, not only will they be carbon negative, but they plan on removing their historical carbon emissions by 2050. and then they put $1 billion US into a climate innovation fund. So they're really putting their money where their mouth is to become a good steward of the environment. Similarly with Apple, they want to remove carbon from everything they do. It's one of their lighthouse projects, one of the biggest projects they do. And then over on the side, Intel's done a similar look. If you looked at how efficient the IT industry has become, Intel's a good barometer for that. And over time, they've made their processors and their equipment hundreds of times more efficient, and together with the server manufacturers that are now, because of virtualization and composable IT, able to make one server do what we used to have 10 or 12 doing. It's really been a tremendous gain in terms of time. So they compare it to, in this one, it's a little hard to see, but if the airline industry from the last 20 years did what Intel did just with processors, then New York to London would take 8 minutes, and the fuel consumed would be 2.5 liters. So that's how significant the benefits and the efficiency gains have been on the IT side. Just really, really incredible stuff. So you remember earlier I showed this slide. Where were we? Where we begun? How did we do? So I probably have hung in here this long. You figure it's probably going to be a good story, and it is. We did actually do very well. This shows from 15 to projected the internet traffic and data center workloads. This is in percentages, but essentially the energy use has plateaued, so it's more towards the lower end of that thing. And it stayed, you can see it rises a little bit in 18, and then it comes back. Stayed essentially flat in terms of overall data center energy use. And this is from the IEA, so this is an independent, the organization. All the sources are cited in here, and you'll get the full presentation later. While workloads are more than tripling, and traffic is, at this projection, was going to be up 5 times by 21 over 15. We've talked to some of our large customers. Microsoft, for example, they said their Azure traffic has gone up 7 times just since the crisis began a month ago. So the workloads and the internet traffic is really, really going up tremendously, and we're able to do that efficiently and sustainably with how we're designing our data centers and how we're using our energy now. So really a good story in terms of what we've been able to do. So with that, I'd like to open it up for some questions. And I'll also
Thank you, Dave. Oh.
No, you're fine. Do we have any questions, Rachel?
Yes, there are some questions coming in, but if you have others, you can still enter it into the Q&A section, and we'll answer as many as we have time for today. So the first question I have is, why do we not see a much bigger adoption of on-site renewable generation in the data center industry?
Yeah, I think that's a great question, and I kind of hinted at it earlier. Was part of it is that where the data centers need to be isn't necessarily the best location for renewable generation. We saw that Northern Virginia in the U.S., there's other similar sites, Singapore, places like that, don't either have the climate for having on-site generation. You think of solar. Solar requires a tremendous amount of space. And then these are kind of urban areas, Singapore, Northern Virginia. Real estate is extremely expensive, and rooftop solar wouldn't be able to support that in an effective way. So I think that that's one thing that happens. Now, that's not to say that we're not using renewable energy, of course. I think the power purchase agreements are definitely the way to go. And you think of, Google, for example, has built solar high 200 megawatt plus solar plants in the Mojave Desert in the Southwest, and then bought back from the utility company, Bonneville Power, whoever it is, that same 200 megawatts to use in their facilities in the San Francisco Bay Area, for example, or wherever. So I think that's the way to go. that also gives you a degree of consistency as well. Of course, renewables are a bit, as we saw from that curve, they do vary over time. Whereas if you do a power purchase agreement, you're adding that 200 megawatts to the grid, but you're able to draw it when you need it at night, for example, with solar, or when the wind's not blowing or whatever. So it's a good solution for that.
Thank you. Another question we have is, where does DCIM fit into the overall industry, and how can it help sustainability?
So DCIM, for those who aren't familiar, is Data Center Infrastructure Management, and it became a way to do resource planning of your IT loads, and then it expanded into some facilities and power management things. So really, where I think it fits, and we've seen it used, is for energy management and actual data center automation. So it can help make sense of what's becoming a very complex energy landscape, a very complex power topology. How do you manage all those resources? What are they doing? What are they telling you? IT utilization can be moved around, and you can apply things that have been learned through other industries for that. So, to be honest, the best place to learn about that is in our upcoming Digital Data Center Operations seminar in June, which will show you really get into this in great detail.
Great. Another question that came through is, in the future, will data center operators be willing to pay a premium for renewable energy?
That's a good question. I think that right now, we think that in co-location, for example, co-location is where you hire somebody, a data center specific company to do your IT services and your internet presence. And so if that's not your primary business, then you would use a co-location company to do that. So it would be typical for, pick somebody, Ford Motor or somebody, that's not their primary business, but they want an internet presence. They want that, so they might hire a co-location company. If you're choosing a company to do business with for co-location, it would make sense that I'd want somebody to be as green, as sustainable as possible. That helps my corporate sustainability message, right? So I think it's becoming more and more common there, as well as the cloud giants, the Amazons, the Googles, the Microsofts, are all certainly very, very interested in the sustainability aspect of renewables, and they would be willing to pay a bit more for premium, or pay a premium for energy.
Thanks. Another question is, what's the first step to take towards more sustainable operations?
I think it's like many things where you can't manage what you don't measure. So be mindful of what you're actually using and consuming. The first steps taken a decade ago are very simplistic. They were, turn down the thermostat on the or turn up the air conditioner, turn off essentially the air conditioner, because you don't need things that cold. Be mindful that some of your servers may be running as zombies. The old joke was, what's the sure way to limit your career in IT? Turn something off that should be turned on, or left on, rather. So there are some servers that folks would never turn off. Guiding airflow, segregating hot from cold air, it all adds up to money, and it's something that's relatively easy to do. If you're talking on power side, we've gone from using louvers for airflow to using variable frequency drives on fan walls and things. On power side, for UPSs and power quality, we've changed the topologies. They're much more efficient. It's very common now to have a 97, 96, 95% efficiency rating on a dual conversion UPS, which used to be unheard of. So tremendously more efficient there. I mentioned Harmonics. That's something to consider. The better power supplies for the IT equipment. Be mindful of the refresh cycles, etc.
Thank you. Another question that came in was, what are the basics of a renewable or green energy strategy?
Yeah, that's a good question. I think the right now, right this instant, the power purchase agreements are the place to start. So, I mentioned how Google helped build a solar plant in the Mojave at a lower level as a consumer, a smaller consumer even. You can choose your energy sourcing thanks to deregulation of the electric utility industry. So you can choose your generator. You can choose your what type of energy you're buying. So that's really, you get the best of both worlds, in my opinion, and I think that's the way to do it. Obviously, limit the use of have the topology design so you can limit the use of diesels. It's not the way to go, obviously. Even so far as maybe when you're doing a refresh of IT, consider adding longer runtime to your UPS system. That could theoretically limit the use of diesels, right? So I think there's a couple things that you could do practically that don't necessarily require a whole redesign, just require some smart consumerism and some smart planning.
Great. And we did have a question on the last slide where you outlined how we did. We want to clarify whether that's a global or a U.S. perspective.
So this is from the IEA. So this is actually a global energy use perspective.
Great. There's another question on the Open Computer Project. So will the Open Computer Project impact electrification architecture, in your opinion?
Yeah, so Open Compute, for those who don't know, was a Facebook in probably close to a decade, I think, when they built their Primeville, Oregon site, decided to use industrial electrification to do it. So if you imagine the one lines we showed earlier, they went more towards the left of the existing topology, made a simpler one line. So imagine an A and B feed where one side was 480 volt AC, which is a common industrial voltage here in the U.S., and the other side they used a combination of at the server level it was actually direct current. So direct current's interesting because obviously batteries speak direct current, but interestingly all the renewable energy does as well. And it doesn't require synchronization and complicated controls in terms of how to do things. So if they used some specifics around how to do that topology, but it ended up being a win for them, and it made their whole system better. So I think that's one of the ways to go. The Open Compute has been very interesting in terms of what they're doing. Some designs have featured little batteries like the ones in a DIY drill, the home level, consumer level drill, cordless drill in the server itself, which makes the UPS obsolete, for example. But then you end up with, what do I do with all these little batteries and what's the health of them, et cetera. But it's certainly something that we support, and we work within that topology. I go to the Open Compute Summit nearly every year. This year, unfortunately, was canceled. That's a path forward. I think that we're in an exciting time because there's going to be a bunch of paths forward. But Open Compute, the flip side of Open Compute is you do need to have kind of it's not 19-inch racks anymore. You go to a larger rack. The IT equipment's a little bit specialty. It's not crazy, but you just need to be aware of a couple of things. But it's certainly a great way to become more efficient, more sustainable.
Great, thank you. Another question that came in was, how easy is it to quantify the impact of harmonics on your efficiency?
Yeah, that's a that's a good one. What we've done and what folks are doing is at key places around the data center, they're actually um, one thing to do is in the past you would rent like they call it DRANA. It's like a oscilloscope and a recording oscilloscope, and you put it on there for a week or whatever. With the technology available now, you can actually monitor that all the time. So even down to the lowly circuit breaker, power circuit breaker on UPS output or at critical power distribution level, you can record and get the harmonics contribution in real time. And both ABB and others we're recording things out to the 50th harmonic, so you get a really good idea what your total harmonic distortion is, et cetera, with off-the-shelf circuit breakers. Now, they're obviously that kind of resolution adds some dollars and cents to the price, but if you deploy them in the right areas where you need them, it really starts to build a picture overall. And all these efficiency things are best when looked at through a longer time lens, so this allows you to do that.
Great. I know you touched earlier on the first step that we can take towards more sustainable operations, but if you could take it a step further and discuss what some next steps would be towards sustainability.
I think the next steps will be things like using industrial automation platforms to really run the operations better, and that's what we're seeing. So once we have the smart, smart switchgear, smart UPSs, the smart components in there, and then if we have something like a full-featured DCIM system or a data center automation system, then you can look at things like how can we run the controls with a feedback loop. And the feedback loop now, and famously Google did this, where they put an AI engine on their HVAC controls, and they were able to reduce, without changing a single nut or bolt in the building, reduce their consumption of electricity on the HVAC side or on the air conditioner side by 40% in the first month or two. And so I think the next step is going to be more autonomous control around data center operations.
Great. We had another question. I think we'll have time for one or two more. Um, has the data center industry topped out in terms of growth?
No, I think definitely not. What's changing though is we're going to see that for things like 5G, for enhanced AI, autonomous vehicle feedback, things like that, you're going to probably see growth in different spots. The sheer amount of data required for what's it called, massive 5G, which is a couple 100,000 devices or 5 million devices per kilometer. That sounds about right. Anyways, is going to require a lot more bandwidth and a lot more data center support. Data centers themselves will probably morph a bit to this. We think that there's going to be right now we haven't seen a lot of, for example, AI nodes. I think that's going to be very impactful, but also impact the requirements around things. We're talking with folks about seeing more power usage, seeing more liquid cooling things, but using the resources we have as well. So we'll see a lot different topology, I think, moving forward. But it'll not even close to topping out. I think we got another decade worth of significant growth.
Great. I think that's a good stopping point as we're coming up on all the time that we have for today. So to remind you when you exit the session, you'll be prompted to fill out a survey, and we would appreciate any feedback that you all have on today's event. Once again, thank you for joining, and we hope to see you in a couple of weeks for our Sustainable and Scalable Technologies webinar.
Thanks, everyone.